Right, today's test is going to be the Garrett Vx9 Vortex. It's first one of these I've actually had to test. The purpose of the test, of course, is to find out what maximum performance is I can get out of it. So it's packed with loads of discrimination options, but I won't be really getting into those. Might touch on them later. It's running on version 9.13, but at the time of making this video was the latest version. Apparently there was a few problems with the earlier ones, which I'm not that privy to be perfectly honest. So I'll just take it as is. So we've got all these options here: zero, standard US coins, custom, fast, and coins. Mainly going to be discrimination patterns revolving around that. I might try the thin coin one out later in case it just does something a little bit different. But I've got it on multi-frequency because I can't see any point in having it on single frequency when I bought it as a multi-frequency detector. And we got the volume and sensitivity. This is the sensitivity, which I'll whack up to 8, and the volume on 8 as well. That's iron volume, which I'll leave for now. Multi-frequency and all the other options. This is the channel adjustment where you can move it around should you be having interference from electrical cables, other detectors, etc. That is your sweep speed, which I've kept it on 2, which is a nice average one. You've got a choice of 1, 2 and 3. 1 being technically the slowest and deepest. We might move on to that later to see if it makes any difference. Backlight, headphones, wireless one should you wish to pair some. That's your button type lock should you be 60 meters under the sea and want to stop your buttons from switching themselves on. That's not going to happen. And 5 tones I've got it on at the moment, but I'm going to change that to 3 tones. I've also got the choice of 2 tones and 1 tone. That's my notch, I presume, and another discrimination type feature, another one as well, which is a bottle top reject. That's another iron blocking feature somewhere, a large iron I believe. That's your audio for the iron. So there's a lot of features there in terms of discrimination, which I'm not going to get into. I just like it to leave it as open as humanly possible and make my own mind up. So that's off. Right, we'll get on with the actual test. Right, on to very low conductive targets to start with. We've got a gold chain, 20 inches long, rolled into a ball 1 inch deep. It's a bit all over the place, but chains are very difficult, especially if you roll it into a ball. I'd probably have to dig that. Gold chain, 5 inches long, 1 inch deep, stretched out. That's a less complicated signal, gets that quite happily. Fine silver earring, 1 inch deep. Small Roman bronze, 3 inches. Small pewter button, 4 inches. 6 inches. 7 inches. 8 inches. Just about. It's on the border. Coke. That's coming in at a nice 40. Go back to the Roman bronze. I can't remember what that was. 48. And the gold chain. 48. So yes, we can actually eliminate coke and pick up gold chains. Galena. 6 inches. 177 air rifle pellet, 4 inches. Right, small, thin copper ring at 8 inches. Just. And the same again, only slightly larger copper ring, this is at 10 inches. Yep, no problem with that one. Onto discrimination and separation. This is a iron cord 2 pence. Audio wise it's rejecting that, but it's all over the place on the screen. Obviously it's an iron cord coin, so it's mainly iron, but 99% of detectors get that. It's a crown bottle top, again it doesn't get that. It's got a very high iron bias on this, somewhere along the line, in comparison to other detectors that is. 2 coins, low and high conductivity, 8 inches deep, 1 inch apart. It's weird because that seems to be getting both coins. Yet I haven't found a detector yet that does that. Definitely different, this thing is. Same again, only 3 inches deep. Can hear it more so on that. Ring pull and 20 pence. Can we separate them? Ring pull. 58, 20 pence. 59, a bit too close that one is. 3 inch deep iron low conductive coins with a steel staple rusty one in the middle. Yeah, getting all 3 of those. Low conductive coins for 5 pences. We'll start at 9 inches. Getting it. 10 inches. It's a bit all over the place at that. 11 inches. Nope, perhaps that was a bit optimistic starting that high. Let's go down to 7 inches, see what it sounds like really. That's the proper job. Right, cut quarters. 5 inches. Six inches. I've been optimistic on that one. I tried to do a 4-inch one. Yeah, it's a bit more positive on that. Well, just nearer the surface, I suppose. 5 pences on edge. 5 inch deep. 5 pence. And across it and down below. They've seen it as iron on that. 6 inches deep. Down below. Some detectors, for whatever reason, do not like 5 pence. It's 5 inches lengthways. Right, we're going to the 7 inch one. And down below. Get those better than the flat ones. Right, onto the high conductive targets. Georgia 3rd 8 we'll start at 9 inches. Ten inches. Better we're getting the high tone coming in now, which that's what we should be getting. 11 inch deep half penny. No, it doesn't like that one. Georgian halfpennies on edge. We'll try the 7-inch one. Eight inches. No. Cartwheel pennies. 11 inches. 12 inches. 13 inches. Yes, diggable, that is 14 inches. Nope. Right, on to the cartwheel pennies on edge. This is 8 inches. And down the length. No problem with that one. 9 inches. Across. And down the length. I think could I have had a 10-inch one buried? I don't think it would have got that. Onto the artifacts. Musket ball, 7 inches. Small bottle, 6 inches. Small bottle, 8 inches. It was coming as a big iron, so I don't know what he's seen down there, but know what the detector sees. See it from the other way. Yeah, get it from that way. No idea what he'd seen down there. Fibula, 5 inches. Horse harness bottle, 15 inches. Large musket ball, 10 inches. Mixed signal there, what you would normally associate with iron. Fibula, 7 inches. Large lead weight, 14 inches. Shows signs of being able to do it, but it's just not right. Thimble, 12 inches. I won't bother with any of those, it ain't gonna get them. Right, onto the silver coins. Victorian silver threepenny bit, 6 inches. Sixpence, 7 inches. Silver shilling, 8 inches. Edward the First hammered penny, 6 inches. Hammered silver threepenny bit, Tudor. Iron apparently. Silver threepenny bit, 8 inches, milled one. Gets that quite happily. Sixpence, 9 inches. No. 10-inch deep shilling. Florin, 12 inches. Half crown, 14 inches. Nope. Onto the iron and oars. This is a horseshoe, 6 inches. It's all over the place like this, so it's obviously seen that as iron. Iron bottle, 6 inches. 20 pence, 8 inches deep, with 3 nails sitting directly on top of it. It manages to see iron everywhere else, but on an actual hole with 3 nails down it, it doesn't seem them. It's just getting the 20 pence directly underneath the nails. Same again, only the nails are now 4 inches above the 20 pence. See my nails now, just about. £20, 8 inches deep, 3 nails on the surface virtually 1 inch down above the 20 pence. As you see now, it's gone silent, and we're getting the iron coming in at the bottom. Turn it round to one side. I'm not that convinced it's getting the 20 pence out. I think it's just getting the nails because it's a different angle, but who knows? I have little trust. Knife blade 2 inches deep with 2 copper rivets sticking out of it. We're getting iron so far, and if I wander around it, see if it'll pick the rivets up. It is doing, but I don't think I'll be digging it. Large nail 6 inches deep with 20 pence sitting on top of it. As you can see, it's on the screen, it's quite happily getting the 20 pence, which is sitting on a bloody big medieval nail. It's crackling quite happily, but the iron isn't coming through yet. The iron target is about 20 times bigger than the non-ferrous one. Come back a bit. Now it gets it. Halfpenny 6 inches, coke 1 inch directly above. That's the coke. Move forward and we'll probably get the halfpenny, hopefully. Yep. Penknife. Non-ferrous and ferrous. And we aren't seeing any iron coming up on the screen. Horseshoe 2 inches, 20 pence 6 inches below it. Getting the horseshoe. See if he'll get it from the side. Now it's going diagonally under the horseshoe and getting the 20 pence. That's pretty good actually, but you know. 20 pence 2 inches, horseshoe 6 inches. Now it's going straight through the 20 pence, which it's ignoring, which is virtually on the surface, and getting the horseshoe, which is 6 inches below. Very rarely do I get a detector that does that. But if I go from one side, rotate slightly, we get it. 6 halfpennies, 11 inch deep, stacked on top of each other. 100 mixed coins in a pot 20 inches deep. And last but not least, there's 6 halfpennies in a row on edge, 2 inches deep. Sees his iron that way, all detectors seem to do, and gets it the other way. I said that before I tried it, but yes, it does. Just a quick here, just show you this bit I've discovered. We've got a George III halfpenny at 13 inches here. No other detector I've tried yet has got it. This doesn't get it, it just comes in as iron there. But obviously it's getting it, it's just seen it as iron. 14 inch halfpenny. So it's coming in as iron again, a bit of a grunt there. If we put a tone onto the iron, like so, go back, 13 inch. Gets that quite happily now. It's coming in as iron, and it's giving me a number 13, which is obviously way off the mark, but he's getting it quite happily. The 14 inch one. How easy that is to get. But it seems as iron. This detector would be an actual world beater if a discrimination worked at depth. It doesn't on most detectors. Normally you don't get a detector getting a 14 inch halfpenny that easily. It's just coming out as a wrong result. If Garrett could fix that, then this would be the best detector in the market. Before the test, I didn't investigate the problems I had heard it came with this detector. Thought I'd come to my own conclusions first. Anyway, I was using the latest software version 9.13. It had apparently ironed out most of the problems, whatever they were. I had no idea what it was like before. Anyway, my findings were it saw targets in a different way to most detectors I have tested in the past. I tested it 5 times on my test bed and got different results every time. Discrimination is very odd, and in my opinion, the iron bias needs lowering to start with. But I think it has a few more issues other than that. The smaller ripper coil gives different results to the 11x8 radar coil and seems, I suppose, a lot more normal results-wise. My findings over the years are that 75% of the time probably that the coil is what is the thing that is causing these problems. I say, but I'm by no means an expert in these things. I'm just going off experience, really. I really do struggle, I suppose, and find it very difficult to understand why virtually all the detectors that are released nowadays are not the finished product, or at least 95% there. Is it because they need to get them up for sale as soon as possible, regardless of the problems they may have? Surely this gives the detector bad press straight away and seriously knocks any future sales. I remember when the Garrett Apex came out, it was terrible in the comments I made on my blog at the time, where doesn't anyone ever test these damn things before selling them? Now a year or two on, with a few updates, it's a great detector, but of course nobody seems to want them. I cannot believe that manufacturers cannot employ someone who knows something about how a detector should work and what is expected of it. It isn't rocket science if you're in the business, surely to God. You only need some sort of simple test bed to run over. It's getting to the stage now where it's pointless buying the latest old singing old dancing detector, because you probably got to start building it when you get it, and then 2 years down the line it'll probably be what you thought you were buying in the first place. Minelab seemed to get it right, so why can't others? So anyway, after the test I went online to see what the problems were or are, and pretty much they were similar to my findings. The alarming thing, I suppose, was that I was using the latest improved software, and where the comments online were relating to the older software, so God knows how bad it was before. I was going to do tests on all the frequencies and things, but obviously there's going to be more tweaks going on with this detector, so it's pointless doing anything else with it. So I've just listed my findings so far. No doubt when we actually finish building this detector, I shall test it again and see how it's improved. And if we do tweak it and get some joy out of it, it's probably going to be the best detector on the market, as I mentioned earlier. But we'll see how it goes. Anyway, thanks for watching. I shall be back very shortly with another video, no doubt. And bye for now. See you soon.